Woohoo! We are live. This is Math 40 Elementary Algebra, and we're in section 2.4, working with formulas to solve word problems. This is part 2. We've already done a couple of them. We're going to do a couple more, and then again there will be another video there's one other topic in this section. It's kind of a jam-packed section. Ooh, mirrors. And so let's go ahead and get right into it. The Rose Parade floats. So those are the Rose Parade is the big parade on January 1st, I want to say, the first of the year. For the Rose Bowl, everyone puts together beautiful floats for the parade. So they travel down the 5.5-mile long parade route at a rate of 2.5 miles per hour. So I've got miles and rate. How long will it take a float to complete the route if there are no delays? Now, of course, that's a funny thing. If you've ever seen a parade, they actually start, la la la, and then they stop. And then they start, la la la, and then someone has to sing a song and everyone gets out and dances. And then la la la. And so obviously in the real world, the parade floats do not just keep going because they would run over all the dancers. It would be horrible. But we're going to pretend that the parade just starts and they just keep going. And the reason for that is that that's the easiest thing to talk about in math. If you want to start bringing in the float starts and then it stops and then it starts and then it stops, then you've got to use more complicated techniques. So that's not going to be this class. Maybe another class. Maybe you will get to a point where you get to do that. But for us, we're going to stick with the very simple assume there are no delays. So I want to look through my formula sheet for something that talks about distance, about rates, about time, how long, that's time. So if I look through here, I see I've got my DIRT formula. D equals RT. Distance equals rate times time. And this is a really important one. This comes up a lot in math and in physics and in calculus because it governs the motion of a lot of things. People, Rose Parade floats, planets, stars. So it gets spaceships. It gets really fun. You can do a lot of really interesting things with this formula. Okay, so I'm going to read again, but I'm going to remind myself that I'm looking for distance, I'm looking for rate, and I'm looking for time. So I'll grab blue for my distance. Let's see if we can find distance. The Rose Parade floats travel down the 5.5-mile long, look at that, we're right there. 5.5-mile long, so it's 5.5 miles. Woohoo. Okay, what else do I have? I'll grab a green one. Nope, I won't. I'll grab a pink one. At a rate of 2.5 miles per hour. Okay, I see another number here. 2.5 miles per hour. I've got rate or time. It uses the word rate right there, so I'm pretty sure this is a rate. Also, I will tell you something interesting about rates. It says 2.5 mph, which is 2.5 miles per hour. Rates will always be given with a per. Remember, we were just doing percent, and that was divided by 100. This is miles divided by hours. So you'll always recognize a rate by the word per. So if you see the word per, you got yourself a rate. Okay, and then let's look for time. I'm going to guess they're not going to give us time because that's the thing we're trying to find. And sure enough, how long will it take? So it's telling us we don't know what the timing is. So that's our question mark. Okay, let's set it up. It's a nice, simple formula. D equals R times T. My distance is, and I should say, wait, before I get started, I got so excited to get started, but before that, let's double check our units. Remember, units have to agree. This is miles, good. This is miles, miles per hour. So the miles, these two agree. And then if this is miles per hour, what does time have to be measured in? You've got it, hours. So these two have to agree too. So if you put numbers together in a single equation, you have to make sure that the units agree. Now, will they always agree in this class? They will mostly agree in this class. As you move up through math, hopefully up towards calculus, by the time you get to calculus, nothing agrees. Everything is a mess. You have to redo everything all the time. It's super fun. But in this class, for the most part, they're going to be like, oh, look, they agree. Every now and again, you're going to have to convert. And when we get to that point, I'll show you how to do it. Okay, so my distance, remember, leave the units off. So I'm just going to include the numbers. Distance is 5.5 miles. My rate was 2.5. And then I've just got a big T there. Notice I don't have to write multiplication. I didn't have to there. I was emphasizing it. But I can just put these two things together because they're different kinds of things. And when you put things together like that, it's multiplication. Okay, what should I do? I got to get T by itself. So what do I want to do to both sides? You got it. I'm going to divide both sides by 2.5. And again, if you put the pen in, you'll have one of those on each side. Okay. Those cancel. Yay, I've got T on the right. Shall we discuss the T? See me being cool? I'm cool. I know how the kids talk these days. Everyone always says, let's get together and solve for T. Yeah, totally. Okay, so 5.5 divided by 2.5 gives me, ooh, something nice. So this is what I'm always hoping for. Whenever I've got an equation and I'm having to divide, I'm hoping that I don't get a long number. If I get one that's long, then I'm going to have to either solve it a different way, like using fractions and reducing, or I'm going to have to round. So this is lovely. I just get the lovely number 2.2. Now, you can ask me, is there any way to get to this without using a calculator? Absolutely. You can go ahead and reduce this, and it is possible to reduce. And if you guys are curious, ask me, ask the tutors. We can show you how to use fractions and reducing fractions to get to a nice number. Now, another little tidbit about word problems. And in Math 40, I don't expect you to follow all the rules. This is our introduction. And so I figure I am happy if you can get through the problems. I'm not going to be all picky about how you do it. As you go further in math, we get pickier because you've got more practice. And so you can develop the other skills. This is a very subtle part of solving word problems. But see how these numbers are both listed as decimals? If the problem itself is stated with decimals, then you should generally answer with a decimal. If the problem is stated with fractions, you should answer with a fraction. If the problem doesn't give you any hint, then you usually get to choose which direction to go with. So that's another reason to know, okay, 2.2 is good. So my time equals 2.2. And then remember, I have to use units. So I go back up here where I was working everything out. And I'm like, okay, this is miles per hour. That's right. So this is hours. So it's 2.2 hours. Now, here's the thing. Depending on who you are and what you do for a living, 2.2 hours might be perfectly reasonable, or it might be really weird. Like a lot of the humans I know would be like, what's 2.2 hours? So this is 2.2 hours equals 2 hours and so many minutes. We don't know. So how do you convert to minutes? Well, here's the trick. So 0.2 hours what you're going to do is you're going to take this and you're going to say, I'm going to take 0.2 and I'm going to multiply times the number of minutes in an hour, 60 minutes per hour. So what is 0.2 or 2/10 of an hour? Well, if I multiply 0.2 times 60, that gives me 12. So it's 2 hours, 12 minutes. So that's another answer you could give. Personally, I think this is perfectly fine given the decimals they use here, but just if anyone ever asks you, you can also convert it to hours and minutes. Woohoo! You guys are brilliant. Okay, I got great news. You guys ready? One more problem. Woohoo! Yay! And oh boy, it's the problem. Okay, so we're going to convert degrees Celsius. And I found this problem and I love it because it really, in a physics sort of way, it plays with my brain. So let's come here. The example is to convert 2,212 degrees Celsius, which is very high, the temperature at which silver boils. So that's a really weird idea. So you know how when you heat up water on the stove, water starts to bubble and then becomes water vapor, becomes steam? This is the temperature at which, if you put silver, like the hard silver metal, into a pan, the problem is the pan would disintegrate. So I don't know what you would put it in, but you put it in something even that doesn't melt. And then if you could do that, if you could cook silver on the stovetop and get it this hot, the silver would liquefy, would become liquid and would start to bubble, and then you would get silver gas. And that just is amazing to me. Okay, so we want to convert this temperature to degrees Fahrenheit. So this one, the one thing about this is nice because temperature, we know it's this formula. C equals 5/9 times F minus 32. The problem is that we know the degrees Celsius. We do not know, we want to convert to degrees Fahrenheit. We don't know the Fahrenheit. Okay, so what are we going to do? Well, cry, maybe. Crying is always an option. Always. I mean, I don't know that it helps you with the math, but it certainly gets some emotion out, so then you can focus on the math. You know, so if you want to cry and scream and throw things at the wall, awesome. Make sure they're soft. You know, or, you know, bring in your support Godzilla who loves you. I should put a little heart. I should give him a little, or her, a little heart. Okay, so 2,212 goes on the left. 5/9 times the quantity F minus 32 goes on the right. And now I am sad. Now, the good news is I've got a really cool trick. I wanted to do this problem because I wanted to show you. I think it's cool. I find it satisfying. So I'm going to remind you, there were those rules that we went over that said you can do anything you want to the left if you do the same thing to the right. So we just got to balance. And I've got this really, really annoying fraction, 5/9, which is not nice. It is not nice. It is a repeating decimal, 5 divided by 9. And it is an annoying repeating decimal because it rounds up and it's just, ugh. So we cannot deal with this in decimal form. We've got to keep it as a fraction. But let me suggest this. So leave yourself a little room on the right side. Let me show you the trick. What I want to multiply on both sides, I'm going to use my red because it's going to be different. I want to multiply by the reciprocal. Notice when I've got one on the left and I've got one on the right. Now, why is the reciprocal so great? Well, over here, the 9s cancel and the 5s cancel. And so on the right-hand side, No muss, no fuss, no fraction. Ooh. So that's kind of cool that you can multiply both sides by 5 or by 9/5 and cancel the whole fraction. Now, unfortunately, we can't just go about our lives because now we have a fraction over on the left-hand side. It happens. So let's take a look at what we could do with this. Well, I can go ahead and write it as 9/5 times 2212 over 1. So I could use my calculator. I could try to reduce the 5. The 5 doesn't go in easily, so let me see if I can do it on my calculator. So what do? You multiply across the top, 9 times 2212, and you multiply across the bottom, you just get the 5. I'm just going to write F minus 32 over here. It's just going to hang out while we figure out the left side. I'm going to ask Godzilla nicely to move. Give myself some more room. So I've got 9 times 2212 all over 5 equals F minus 32. So let's go ahead and try this. I got to do this over here. 9 times 2212 equals, I get 19908 over 5. And let me divide by 5. And I get a very nice number. Isn't that a lovely number? It's a very large number. 3981.6, 3,981.6 degrees. But I'm not done. I got that decimal, and then what am I going to do? Well, I don't need this. Black. I've got an F minus 32, so I'm going to add 32 to both sides. And then it's still on my calculator, so I'm just going to add 32, and I'm going to get 4013.6 equals F. So the Fahrenheit, the degrees Fahrenheit, the temperature is 4013.6 degrees Fahrenheit. Now, the degrees is technically the unit, but you should specify it's degrees Fahrenheit since we're working both with Celsius and with Fahrenheit. So you guys, we did it. You're awesome and amazing. You made it through 2 really long videos. So, maybe consider taking a break, go outside, remember what the sun looks like, and then come on back in and we will do the second half of this section, which is just a bear of a section, I know. We're going to do some manipulation of formulas and then we'll be done. Woohoo! Okay, congratulations, guys. Math on.